Hello and welcome to another CS200 mini lecture. Today we'll continue our Chapter 12 Inheritance discussion, and we'll talk about subchapters 12.4 through 12.6. Let's get started. The object class is one in which we call the base class for all the classes that we might create. So this serves as the base class for a couple of reasons. First of all, because of inheritance, any class that we create has to have certain properties, and the object class helps with creating these properties that we can continue with any class that we might create. So for example, the toString method here returns a string representation of an object. So if we have a bunch of integers and we want to convert them to strings, we might use the toString method. And this is part of the object class. Another is the equals. So I'm sure in CS160, when you're comparing, say, for example, one string to another, one mistake that is commonly made is you use the double equals in your logic. So you'd say if string 1 double equals string 2, and you get it doesn't work the way you expect. It's because what the double equals does is it looks at whether the things are pointing to the same item. So what we do to this is we use the equals and say, for example, we have string 1, we do dot equals in parentheses string 2. So what happens is the equals method compares these two objects, and if they point to the same object, it says yes, they're true. Otherwise, it returns false. So here's an example of a business class derived from object, and you can see that we have spoken about this earlier, but we have things like name and address, and you can see that get a description, we return name and then double hyphen and address. So you'll see here in a minute, we'll overwrite get description or the toString method that we've already derived from the object class. So let's go through this exercise because I think it's important to kind of illustrate what goes on. So in the first, we see that the object class is the base class for all other classes. Okay, so we're creating a new object here called myObj. Next, we have an integer that we create, and then business. Now notice that business doesn't override the toString method, and we'll see that in a minute. So the integer class overrides it, but business class does not. So when we print out the items, what we do is we get myObj equals myobj.toString, and you can see what it's printing out is the object name, the @ sign, and the actual hex address in memory. So that's what we get when we run this. So with a number, we're actually overriding what the default method is with the object class, and it gives us the value in num. So remember, we're using toString in both cases. In this case, we're getting the value which we expect. With the object class, we just get the object name @ and then the memory address and hex. So with some business, again, it doesn't overwrite the toString method. So what happens is we get something very similar to what we got with the object. So the toString method, again, doesn't override what is created in the object. Okay, so we just need to be aware of these types of behaviors. So here the base class is going to override toString, and we can do this by looking down here. So what we have is we have @override, we have public string toString, and then we want to return name double hyphen and then address. So in this case, we're actually overriding it. Then when we do the restaurant class, we can see that we want to also return what we will see in a minute here, we don't want to just return name and address, but we want to return the rating as well. So when we override this, what happens is, you can see here at the bottom, we do an override in the restaurant class that returns super. Now that goes to the previous base class, which happens to be business. So that's going to do the name, double hyphen, address, and then we're also going to append rating, and then the rating of that item. Chapter 12.5 talks about polymorphism. Now, polymorphism is many forms. So we could have many forms of, for example, our print string based on what we've got. Now, so far, we've looked at some examples that involve compile time polymorphism, meaning the compiler, the virtual machine, is aware of the different forms, because we could have, for example, in the constructor class, we have multiple different varieties of constructors based on what we pass it, what arguments we pass it, so they have different signatures. But now we also have a runtime polymorphism. So let's take a look at this generic item. This is something we talked about back in 12.1. And remember, we could have a generic item. We have a set name method that takes a new name. We have a set quantity that takes a quantity. And then we have a print item. And notice the print item is doing the print line. It does item name and then the quantity. So we have two protected variables, item name and item quantity. Now the produce item, remember, that is one that uses the generic item as its base class. So this would be a subclass or a derived class. So with produce item, you can see we, of course, say that extends generic item, and this is how we make the connection. We have set expiration, because remember, produce items have expiration dates. And we use that as a string, as a parameter. And then we just set expiration date to whatever date we pass in. So it's a very simple method. We also have get expiration, which returns the date if we ever inquire about it. Notice we don't pass any arguments to it, but it returns a value. And then for override, we have print item. And notice that print item is different than what we have in the generic class. Let's go back and look at generic. We have print item here that just does item name and item quantity. But in produce item, we also want to add the expiration date. So we have an override of the print item. And then we also have to declare expiration date as a private string. So now we have item inventory. Now what they do is not very convincing. In their item inventory, what they have is they create an array list. And the array list has a couple of different items. It has the name and the quantity. If it's a produce item, it also includes the expiration date. Okay? So what we want to do is we want to have it decide at runtime whether it's going to need an expiration date or not. Because remember, produce items need expiration dates, whereas generic items don't. The reason why I say this is not very convincing is because the compiler is going to know about all these different variables when it actually does the compile. So what I thought is to do it in BlueJ. So instead of just having these items where we set, we're actually going to prompt the user. Let's take a look. Item inventory that I have does a little bit more. So this is exactly what we have in the textbook, but I've added a couple things. I've added a string called read item and an integer called read quantity. So much like what they do, they create a new generic item, but instead of just giving it and passing it values, like Smith cereal, quantity 9, apple 40, and then an expiration date, what I'm doing is I'm actually going to prompt the user to put that in. So the compiler is not going to know what these values are in advance. So let's go ahead and run this. You can see here it prompts for the expiration date, and then it prints out the items. Okay? So let's do this. First of all, we're going to compile it. Compile's fine. We're going to close it. And let's run it. The first generic item, let's make it, I don't know, cereal. The quantity, let's say we have 5 boxes. And then the produce item, we're going to say we have a lemon. Okay? So we put lemon. We have 1. And let's just say this lemon expires. Let's just say it expires on November 11th of 2020. And again, you can see here that it produces, the output is different depending on whether it's a generic item, which is cereal, or it's a produce item, which we have an expiration date. So what we see here is produce item is going to override the print item that we have specified in the generic item. So this is nice because we have, just like we have here, we have 2 print items in our code here. We also have 2 print items down at the bottom. Whoops. We have 2 print items that we can take a look at. And you can see here, this is where it prints it out. Okay? So the interesting thing here is that it prints out using the correct print item. With produce, it's going to put the expiration date, whereas with the generic item, it doesn't. And it knows to do that just because we know that produce item overrides what we have for its print item method from what's in generic. So there's a way to overload methods. I'm not going to go through this watch exercise, but I suggest that you do it because there's different ways in which we can get output, and it follows just what we saw already. So basic polymorphism, and this is another exercise, a challenge activity, where we might either print out the last name only or the first and last name, depending on what input we receive. This is very powerful because it allows us with one type of method, based on what we're doing, whether we have the base or superclass or the derived or subclass, we can have different behavior based on what is relevant to each different object. Let's look at array lists now in 12.6. So array lists of objects are pretty interesting because array lists could be different data types, so it's important for us to know and understand. Okay, so remember business.java, we have 2 protected field members. One is a string called name, the other is a string called address. These are the constructors. Notice we have different kinds of constructors here. We have one that takes no parameters, and another one that takes a name and address. So then we just set whatever's passed into the name and address field, which are protected. And this is the way in which we could actually create an object that has a known name and address. Now we override the string, the toString method here, and instead of just printing out, because the object has a name and address, remember if we don't override this, what we get is just the name of the object, business, and then we get an @, and then we also get the memory address, which doesn't really mean much. So it's important that we want to override this with meaningful information. And that's where name and address comes from. Okay, so here's another exercise, and we'll take a look at it. So first of all, we're going to create a new array list. We're going to call it object list. And notice that we have to include the Java utility array list as one of the items or packages we need to import. So to do that, we create an object. That's all we've done. So now we're going to add an object. Notice that we're using an add method, which is built into the object or the array list library. So we add a new object. So what we do is we add 12, then we add 3.14, we add hello, and then we add an object called business. Remember what business does. It prints out the name and address, and there's 2 hyphens in between because we've overrode the behavior of the print, which we see right up here, toString. Okay, so when we actually execute this, what happens is we go up here and we print out the items. This is just a way to loop through all the items in this object list array list. So what gets printed here as we go through is, first of all, the object, right? The value 12, the value 3.14, and because the toString method, it just contains the words hello, it's going to override the object's behavior with the string print, the toString print, and it's actually going to give us the value. And now when we print out the business object, you can see it prints it out using the format that we saw we've included up here. So let's see how this behaves. And this is what we get using my computer. So again, the code is the same. The memory address is slightly different because I'm using a different compiler and my memory is set up differently, but all the other values are the same. So here we have another array list. In this case, we're going to create a string called graph, an object called coffee, which has mocha and light, and we have a business which has Dinoco and 2 Park Avenue. So then we add them. Notice we don't add them in the same order that we create them, and that's why the output looks different. So for now, this is summarizing what we've learned. We've looked at different ways in which objects have behavior that's based on an object class, which is the superclass or the ancestor class for all object classes. We've looked at polymorphism and how we can override the behavior of our ancestors, and the way we can actually see that behavior happen or recall it from a parent class is by using the keyword super. And then we've also looked at polymorphism, how we can get different actions to happen or behaviors to happen based on the activities that we want for example, remember the generic item and the produce item, we had that expiration date.